When we finished up on the notes the last time, we started talking about empirical formulas, or what they call simplest formulas. And what's going to happen is you're going to get the percent of a compound, and you have to figure out its formula. So we're going to go the reverse. Before you had the formula and you figured out the percent of each element, well, now you're going to get the percent and you have to figure out the element. And you can either get it one of two ways. You'll get it in percent or you'll get it in grams. It works exactly the same way, you guys. So what you do when you don't want to do an empirical formula, it says assume 100 grams or 100%, okay? But really the first thing you got to do is take the percentage of that element that they give you and convert it from grams to moles or percent to moles. It's very simple. All you have to do is divide by its mass from the periodic table. Then the next thing you do is you got to set up a mole ratio. You're going to, if there's 3 elements, you're going to have 3 numbers, 3 moles, 3 amounts of moles. You're going to look at those numbers, and the smallest one you're going to put on the bottom, and then you're going to put each individual one on top. And the reason why you need to do the smallest one on the bottom is you don't want a number less than 1. Okay? Remember, when we write out formulas, they're whole numbers. So this is one way to ensure that we get a whole number. Okay? So then we do that mole ratio. We put the smallest one on the bottom, and we divide each individual on top. And then when you're done dividing, you're going to have numbers. Now, hopefully they're whole numbers. Sometimes they're not, and I'll show you what you do when that happens, okay? So empirical formula is taking the percentages or the amounts that they give you and finding the formula. All right, calculate the empirical formula. We have a compound that's 63.19% manganese and 36.8% oxygen. Okay, so we've got the percentages. Like I said, this was probably brought into a machine and the machine analyzed it. Now, the first thing we got to do is take each of these and divide by their mass from the periodic table. Well, we got those right here. So this one we divide by 55, this one we divide by 16. Okay, and again, this 100 gram stuff, just take the percentages and divide by their mass. Okay, so take your 63.19 and divide by 55. Okay. You can write out it all crazy like this, but again, just divide by. I'm just trying to save you a few steps. 1.15, okay? Then we do the same thing for oxygen. We take the 36.81 and we divide by 16. Okay, so now we know our moles, okay? So now we've got 1.15 and 2.3. So we're going to look at these numbers and we're going to put the smallest one on the bottom, which is this one. So we're going to divide 1.15, divide it, and then 1.15 divided by, or 2.3 divided by 1.15. You always want the smallest number on the bottom. So let's see. Oh, they didn't even do the manganese. Okay, well, obviously the manganese, if you take 1.15 and divide by 1.15, you're going to get 1. And then the oxygen, you're going to get 2. So you get a 1 to 2 ratio. So your formula is MnO2. Okay, so I wish they would have done the oxygen. I should have probably done that in there. Anyway, but you look at your moles and you put the smallest number on the bottom and divide each, and then you take those numbers and those are your subscripts, okay? Oh, now it shows up. Sorry about that. Okay, so again, here's the smallest number put on the bottom, take each individual, divide on top, 1 to 2, 1 to 2, MnO2. That's the formula for that compound. If we go back here, where you have 63.19% manganese and 36.81 oxygen. Its formula is MnO2. That's its simplest formula. It's an empirical formula. Okay. All right. Now we're going to do what? We've got 72.2% magnesium and 27.3% nitrogen. Again, we're going to take these amounts and we're going to convert them to moles. So we're going to take that 72.2 and we're going to divide by 24.3. You want to divide by 24, fine. I guess on these I'd use 24.3. You get 2.97. That's how many moles of magnesium in this compound. Do the same thing with nitrogen, 27.8, and divide by 14, and you get 1.984. Okay, so these are our two numbers. And again, this is going to be the one we put on the bottom. We're going to divide this by that and this by that. So this will be 1. Okay, so we get 1.5 and we get 1. Now there's a problem here. You can't round 1.5 up to 2. That's too much rounding, okay? If you get, 1.996, yeah, you can round that. Or even 1.97, you can round that. But it was 1.5, that's too much rounding. So instead what you do, to get whole numbers, I'm going to double this and make it 3. Well, if I double this one, I also have to double this one. So this would be 3 to 2, okay? If I got 1.75, I would have to triple them. You got to make sure that you don't round too much, okay? So multiply a number, they'll give you whole numbers. 1.5 times 2 is 3. And then, of course, the other one has to be multiplied by 2. So we get mg3n2. So my formula would be mg3n2. Okay? So you got to be careful when you get numbers like this. You can't round. That's too much rounding. So again, double them both, and then you get 3 to 2, and that's your formula. Okay? All right. What is the empirical formula? We have alcohol. It's 52.13% carbon, 13.1% hydrogen, and 34.72% oxygen. Okay, first thing we do, we're going to multiply this, or divide this by 12, divide this by 1, and divide this by 16. They give you the answer. I did it down here. Okay, so 52.13 divided by 12, you get 4.344. Hydrogen, 13.15 divided by 1, yay, 13.15. Always like working with hydrogen. And then oxygen, 34.72 divided by 16, you get 2.17. So this is the smallest number. So I take this one divided by the smallest number and I get 2. This one divided by the smallest number and I get 6. And this one divided by the small, well, they're both the smallest number, so they're going to be 1. So our formula is C2H6O, and that's what we got up here. Okay? So again, when you do an empirical formula, the amount they give you, divide by its formula mass, that gives us the number of moles. And then set up a ratio with the smallest number on the bottom, and then just divide. And those are your subscripts, okay? Okay, now we talked about molecular formula and empirical formula. An empirical formula is the simplest formula, okay? Now, like we did, we had what? CH2O. Well, there's C6H12O6, so there can be many multiples of it, especially when you're talking about carbon compounds, okay? So when we're doing molecular, what we do is we find the empirical formula, the simplest formula, okay? Once you find that, you take the mass, they're going to give you a mass. You take the mass they give you, divided by its empirical formula, what it weighs, that's going to give you a whole number, and then you just multiply everything by that number. Okay, so determine the molecular formula for glycerol aldehyde. Okay, its molecular mass is 90, and its empirical formula is CH2O. Well, first thing I'm going to do is find the mass of this. We got carbon is 12, hydrogen, well, it's 1 times 2, so it's 2, so we got, what, 14 there, plus oxygen, oxygen 16. So altogether, the empirical formula mass of this is 30. So if I take 90 divided by 30, I'm going to get 3. So then I'm just going to multiply everything in here by 3. So it'd be C3H6O3. I think I got all that. Yep. 90 divided by 30, you get 3. This is what it says it is. This is its empirical formula mass. Okay, that's 1 carbon, 2 hydrogen, and 1 oxygen added together. That's where I get the 30. So I get a 3. So then I take this times 3. So C3H6O3. Okay, that's how you do if you have to find the molecular, if they give you the molecular mass, you're trying to find the molecular formula. First find the empirical formula, and then you just multiply. Okay, determine the molecular formula for nitrogen oxide. Okay, so we got some nitrogen. Its molar mass is 92, and its empirical formula is NO2. Okay, so again, 92 up here, let's take nitrogen is 14, and 2 oxygen, oxygen 16, 2 of them would be 32. So 32 plus 14 is what? 48? 32 plus 14? No, 46, sorry. So I just take 92 divided by 46, I'd get 2, so then I'm just going to make it N2O4. Okay, 92 divided by 46, and again, this is just the mass of this. It's 1 nitrogen, 2 oxygen added together. This is what they told me I have, so I get 2. So then I put a 2 on the outside here, so I get N2O4. Okay, that's, when you're doing molecular formula, it's just one more step. Taking the mass they give you divided by its formula mass, that's going to give you a whole number. And then you just double that or triple it or whatever the number is, turns out to be. Okay, what is the molecular formula for a compound with the empirical? Okay, so we got CH2Cl, and this is what its molar mass is. Again, what I'm going to do is find the mass of this. 12 plus 2 is 14, plus 35.5. What's that? I got my calculator here. 12 plus 2 plus 35.5 equals, that's not right. 5 plus 14. You guys, my calculator's not working. 35.5 plus 49.5. Okay. So I'm going to take 197.9 and I'm going to divide by 49.5. Excuse me. And I get 4. Okay. So multiply everything by 4. 4, 8, 4. And here's how we did it. The mass of CH2Cl is 49.5. Again, that's 1 carbon, 2 hydrogen, 1 chlorine. So if you take this number, what they said the molecular mass is, divided by 49.5, you get 4. And so that's your number that you're going to multiply everything by. So C4H8Cl4. That's how you do it. Okay. Here's a disinfectant. We got its molar mass to determine its molecular formula. So the first thing we're going to have to do is figure out its empirical formula. So again, take 76.5 or 75 and divide by 12. Okay. Take your hydrogen and divide. So we got 12 and 12 so far. And then we take our oxygen and we divide and we get our numbers there. Okay. So our formula, our molecular formula, C12H22O2. What they did here is they multiplied them out. And that's how they got these. This is a shorter version, but if you do this, it'll confuse you. My suggestion is take this, divide by 12, this, divide by 1, this, divide by 16. Find your formula and then multiply. Okay, that'll be less confusing, but this is one way of doing it as well. Okay. All right, here's another one. We got carbon, hydrogen, and oxygen. What's its molar mass is 28. Okay, so again, carbon divided by 12, 7.13. Hydrogen divided by 14 divided by 1, which is nice. And then your oxygen. And what you end up with is carbon, hydrogen. Oh, I'm sorry, just carbon and hydrogen. Duh. 7.13. So we get a 1 to 2. So its empirical formula is CH2. Okay. But its molar mass, if you can't see that, is 14. Sorry about that. So I take 28 divided by 14. I get 2. So double everything. So you get C2H4. Okay. And again, when they do this, find your empirical formula and then take the mass they give you divided by its formula mass and you'll get a whole number. Then you just multiply by that number. Okay. All right. And the video on moles, that's going to be at the end. You can watch that yourself. That I'll put the PowerPoint without me talking on the end, and you can watch that if you want. You don't have to. It's up to you. Anyway, we are done with chapter 7. So next thing, we'll move on to chapter 8.